Question 2. An electrical heater of power 1.15 kilowatts is plugged into a main socket. Determine the resistance of the heating element. Potential difference in the main supply is 230 volts. Okay, so we're going to be using two different equations here. We're going to be using the power equation and also V equals IR. So before we do any of that though, what we're first going to do is convert our kilowatts into watts, because none of our equations use kilowatts as a unit. So 1.15 kilowatts equals, by multiplying by 1,000, 1150 watts. Now we've got that, we can pop that into the power equation. So we can say 1150 equals the potential difference times the current. Obviously we don't know the current, but that's okay because we can do a rearrangement. So we can say that current equals 1150 power divided by the potential difference, giving us an answer of 5 amps. So that's the first part of the question done. We can now use the potential difference and the current to find the resistance using V equals IR. So potential difference equals current times resistance. So what we're going to do is we're going to say the potential difference is 230. That equals current times resistance. We don't know the resistance, but that's okay because we can rearrange to find it. So we make resistance a subject to the equation. We get resistance equals 230 divided by 5.0, which gives us an answer of 46 ohms. So whilst that question can look quite intimidating at first, the two equations we're using are actually quite straightforward. It's just working out the correct one to use in that particular situation, isn't it? So let's have a look at the mark allocation. So we get 1 mark at the start there for the unit into conversion. We get 1 mark for this equation here. Then we get 1 mark for the rearrangement, 1 mark for finding the current, 1 mark for this equation, 1 mark for the rearrangement, and then 1 mark for the final answer, 46 ohms. So that gives us the 7 marks available for this question.